You're listening to Loud Numbers, a data sonification podcast. My name is Duncan, and hopefully you've just finished listening to our episode about Canada's intense 2023 wildfire season, Hold the Line. That episode was a collaboration with the Data is Plural podcast, and so we're really proud to be hosting an episode of that podcast here on the Loud Numbers feed. In it, Jeremy Singer-Vine interviews Bruce McNabb of Canada's Wildland Fire Information System about how his team collects and processes the forest fire data that we used in our track. Let's get started.
Hello, and welcome to Data is Plural, the podcast. I'm your host, Jeremy Singer-Vine. This episode's guest is Bruce McNabb, head of Canada's Wildland Fire Information System, featured in the June 14th, 2023 edition of the Data is Plural newsletter. Without further ado, here we go.
My name is Bruce McNabb, and I'm head of Wildland Fire Information Systems with Natural Resources Canada. It's our job to provide information to Canadians, supporting organizations, emergency management, etc., fire management agencies, and also just to make sure people in Canada and the world have the best information they can about wildland fire in Canada.
What would you say your most in-demand data set is?
I'd say the most in-demand data set is... It's related to hotspots. Hotspots are like signals from satellites of burning vegetation. If I picked one, it's the hotspot-based fire perimeters, which are taking the hotspots and performing an algorithm to provide a best estimate of where is the fire now. And, that changes quickly. Provinces and territories are able to do that themselves, and they are able to map their fires, but especially in that initial period where the event is coming off, you might have hundreds of fires. And that kind of information supports a lot of stuff.
We haven't always had satellite imagery at our disposal. How did Canada determine the perimeters of fires before that?
Airplanes have always been a big part of it. Going back, several decades, provinces have been flying perimeters to try and assess it from the air. But obviously that's pretty cost prohibitive to do, and especially if you have lots of fires. The hotspot-based perimeters are really that first take of here's something where in the first 48 hours, say, of a fire making a big run, it may not have burned all the areas within the perimeter, but this is what we're looking at. I mean, we're still reliant on people on the ground, especially when fires are burning and creating smoke and cloud cover that really reduces the capacity of satellites to pick up the data.
What are the biggest challenges for accurately determining that perimeter or analyzing other aspects of active fires?
One of the challenges is making sure we have enough coverage. Some of the more northerly forests in Canada don't get as many satellite overpasses, especially some of the northern fires in Northwest Territories. So that's something we're trying to address. Canada is preparing to launch a wildfire sat product for, I think it's 2028. And this would be something that would do a much better job of giving more coverage to those fires so we can get more data for the northerly fires.
What sort of data and design decisions go into representing active fires, on a map that will be seen and interpreted by some huge number of people?
One of the aspects, obviously, is just on the design front to give something manageable for people to see that isn't too overwhelming, which was a big challenge this year, especially on active fires, because there was just an unrelenting large number of them. So one of the things there is and we're playing with it now on sort of redevelopment, is how can we communicate fire activity without overwhelming people with thousands of data points on a map? And so for us, it's kind of a balancing act of providing as much data as we can to help people, but also providing data that they can sort of digest. One of the things with hotspots is when satellites go over, it depends on the angle that they picked it up, and so it never appears exactly in the spot, but you have to put it on a map. So a lot of it on that is on communicating and making sure that people are aware what the data is. And so what the data is really reliable stuff from, say, NASA satellites, but it isn't exactly where you see it on the map. So getting the understand that there's a margin of error and all that kind of thing. And of course, accessibility. I didn't realize even 10 years ago the number of men, for example, with color blindness, and that kind of consideration and being respectful and making sure you provide the data in a way that people can use it for understanding and further analysis or whatever it is.
What would you say the most common misunderstanding of these maps and this data are?
I think people have a real tough time with scale. Even really, really clever, smart people don't always get the sense of scale of how big this is, and being able to communicate that these are really, really big fires, and for people to understand that this isn't just, well, I've seen this red dot on the map for a week and a half. Why isn't it out yet? And so I think a lot of it for us is just communicating what fires are like. I think one thing we could do better, for example, is really giving a sense of the amount of energy and heat created, that these aren't things you can go up with a garden hose. These are really big events that are probably more analogous to weapons and nuclear bombs. I don't know. In that sense, some of the big fires have huge energy. These are huge things.
You also publish forecasts. What are the sort of things you're trying to predict, and how accurate are those predictions?
The key part of the forecast is related to how at risk a particular part of the country is of igniting. It's very difficult to say where the ignition occurs. So where someone might be careless with a cigarette, where a lightning bolt hits, where even a power pole might get blown over by wind and start a fire, all these kinds of things. But really, a lot of the forecast is related to a system, which I guess it was conceived in 1925. And the first data collection was 1928 for the Canadian Forest Fire Danger Rating System. And the US has an analogous one as well. I really have an incredible amount of respect for the people who started it, because it's really intuitive. And it's basically a moisture accounting system for different types of fuels in the forest, ranging from the little dry pine needles and twigs on the forest floor, right on the surface, to down lower. If it rained, how much did it wet the soil? Hot, dry, windy days, how much did it dry? It's really trying to assess, if an ignition occurs, how likely is the fire to start and spread? In this type of forest, how big would the flames be? How difficult would it be to control? One of the main sort of feature maps is the Fire Weather Index system, which is trying to provide, here's the risk today, forecast, actual, and we just continually update those, and we do with different data sources.
You've worked at the Canadian Wildland Fire Information System for a while. How did you end up getting into fire data?
My training was in forest management and forest resource management, and I spent a lot of time in forest research. And then an opportunity came to be a manager of an existing team of people, which is pretty exciting in a way, because we are very multidisciplinary. So we have a meteorologist, and we have GIS people and foresters and computer scientists, of course, and all that. And so I really came, I came at it more as an opportunity, to test myself maybe as a bit of a manager and coordinator of this kind of thing. So for me, I've always known a fair bit about forests and nature. I had to learn a lot of the fire stuff, but at least in my job, it's as much about knowledge and mobilization and developing relationships. And I think that's what's so cool about it, is that you really, have to have important conversations with IT professionals, with scientists, with people in the public, with community level people, firefighters, all these kinds of people.
What does a typical day for you look like during wildfire season?
So for us, it's about what seemed like an endless cycle this year of getting the right information and data to people who need it, government, ministers, and that kind of thing. But all the organizations, whether they're the fire management agencies themselves, the provinces and territories, the Red Cross, a lot of different organizations. So it's around that support. It's about direct support for provinces that are facing a really tough situation and they just need some assistance. They're more than capable, but any organization faced like a year like this can always use some help and some other data maybe that they hadn't thought of before. It's also about making sure we're up with the constant cycle of the maps, making sure we produce yet another cumulative area burn chart that suddenly was showing up in all kinds of publications, making sure our website can meet the demand of this kind of year.
And when fire season starts to wind down or you're entirely off season, how does the team's job change?
Well, it's about what we're doing this week, which is learning from 2023. What went well? What could we do better? What are the things we really have to prioritize over the winter to fix? Whether that's technical, maybe it's process related. That's a big part of it, just making sure we do our job better next year. And the other part is we're also embedded within a larger CFS, Canadian Forest Service fire science community. In those cases, it's about developing new algorithms into decision support models. It's about new data sets that we didn't have before. It's about evaluating as much as we can accuracy of predictions and trying to figure out how we could do that in a better way. And honestly, it's as much about cultivating the relationships and trusts. Like, it's technical, but it's one of these things that you don't get to the level of trust where you can say maybe standardize data nationally, that kind of thing. It's about developing those relationships and improving those and all the systems. We need to be more efficient, reduce our downtime. Is there an opportunity to have more frequent hotspot updates so it's even more real time?
Sounds like a full schedule.
Mm-hmm.
You mentioned standardization. What are some of the challenges of standardizing data that's coming from the various provinces?
They're producing this data for their own use. They may not call things the same way. So how can we create some kind of process to convert it to an accepted national standards that no one is queasy about how we call things? Just coming to an agreement that this is, we agree to share this. And, just trying to get to a place where instead of having, for a given field, 28 different, say, descriptions of fire status, can we, it's just coming at something that everyone can agree with, that this is okay, it won't compromise our operations. So the biggest challenge is really doing our work without compromising the work of the provinces, because the last thing we want to do is undercut their work in an emergency.
What are some examples of data that the provinces are collecting?
Well, okay, so they're collecting, of course, their own weather stations. They have real detailed information in terms of where their management interventions are. Like, say, they put in fire breaks. And they're obviously doing cost information and all that kind of stuff. They're mapping fires as well. But we work together to develop something that, hopefully is useful during the fire season, and it's useful outside of the fire season too, to report on things like carbon emissions.
Your team also produces historical data sets. I'm curious, what's the process of taking all of this active fire information, converting it, finalizing it into a sort of a historical data set, a permanent data set?
Our hotspot-based perimeters are just, again, that's our first pass, and people use it as situational awareness. Around this time of year, the provinces and territories are doing more official mapping. So they're using knowledge from the ground, they're using other remote sensing information to fine-tune the burned area, for one thing. So one of the things that happens a lot in fires, you have a perimeter, it's not going to burn every single thing in the fire, it leaves unburned islands. So it's about making sure you have a more realistic perimeter. You make sure you have unburned islands accounted for, because that has impacts for things like wildlife habitat, but also in terms of worrying about next year's fires. And then we have strong relationships with the provinces where we then acquire their end of year stats, and we do have some sort of value added processing that a remote sensing group does using other satellite information at different times to sort of fine-tune the boundaries and get them more accurate. It ends up being a few months to get from sort of the in-season best information to the final perimeters, which we typically are putting in, I think, around May, June the next year.
A big thanks to Bruce for this interview. Our conversation, like all others on the podcast, has been edited to fit into 15 minutes. Additional thanks to Nikhil Sanad, who composed the podcast theme music, and to you for listening. To subscribe to the Data is Plural newsletter, visit data-is-plural.com.